All right, welcome back. We are continuing on with our review, and we're going to start with going over Mini Lab C, and then I'm going to get you on the right track for Mini Lab B. So I'm going to start out sharing my screen because these activities are in Canvas, as everything is. All right, so we're going to start out in patterns practice because that's really what we're doing. And we, the last couple of days, have been working on Mini Lab C and B. So I'm going to start on Mini Lab C. And this links you over to a Google Doc that walks you through a practice exercise with one of our patterns. And the good thing about this is that it uses Desmos. And Desmos is kind of our go-to for this year in physics. All right, so this first one asks you about whether you would get more money if you took the pennies that fit in a 40-centimeter circle or nickels that fit in a 20-centimeter circle. So the first thing that we did was we said, okay, we're going to set up a bunch of circles of different diameters, and then we're going to put pennies and nickels into those circles and count the number that fit. And we came up with two different graphs, as you'd expect, because we have two different size coins. Based on best fit, we said we have two equations. This is the first one, this is the second one. So your first challenge is to figure out which line, the orange line or the blue line, is pennies or nickels. So here's how you do that. I'm just going to start with 10, the 10-centimeter circle. And I'm going to look and say, okay, for 10-centimeter circle, for this coin type, I fit 15 in the circle. For this other coin type, I fit about 23 in the circle. And so since you know that pennies are smaller than nickels, it would make sense that more pennies fit in a 10-centimeter circle than do nickels. So this copper line, this orange line, is the penny line. So you would write penny right there. This other one is then the nickel line. All right, so we look here, equation A and equation B, we got two lines and we have two equations. The only difference between the two equations is the slope. So if you remember from our distance time graph, the greater the slope, okay, it went more vertical. The lower the slope, the more it went horizontal. So from this, we can look at the two slopes and know this is the bigger number, 0.22 is larger than 0.15. So that is the equation for our copper orange line here. So this A equation is for the penny, B is for the nickel. That's how we figured that out. All right, so our questions are, how many pennies will fit in the 40-centimeter ring? Well, we know our equation. And so even though we don't have 40 centimeters down here, we can figure it out by putting 40 squared is 1,600 times 0.22, and it gets us to around 350 or so pennies that we think would fit into that circle. If we do the same thing with nickels, let's see, we're going to use this equation, 20 centimeters. So we just put 20 centimeters in here. We square 20. 20 times 20 is 400. 400 times 0.15 is 60. Okay, so we know we have a lot more coins in this circle than the nickel circle. But remember, nickels are worth 5 times as much as each penny. So if we want to know the value in this circle is around $3.50. This one would be 60 nickels, and each nickel's worth 5 cents. So 60 times 5 is $3, 300 cents. So we get more money if we took the pennies in the 40-centimeter circle as opposed to the nickels that fit in the 20-centimeter circle. So that answers our basic question we asked above. But now we want to ask about quarters. Which side of our graph would the quarters fit? Well, in class, we started out with the copper line for pennies here, nickels here, and I called on a person and they said, oh yeah, if we're going 1 cent, 5 cents, smaller, bigger, quarter is even bigger, so I'm going to guess it's on this side. And so I asked, what would the slope likely be? And they said, well, if it's going more horizontal, the slope will be less than 0.15, because we went 0.22, 0.15, and if it's on this side, I don't know what the number is, but it would be less than 0.15. All right, so we justified our answer, and then in our claim evidence reasoning, we just answered that we said, our claim is that pennies are going to have more value in this circle than this circle. Our evidence is that we ran the numbers through the equation, and we found out this one was about $3.50. This was $3. And our reasoning comes from the graph that we plotted our data from putting pennies and nickels in a variety of different circles, and then used our equations to calculate. All right, so that was our first exercise today. And our second exercise, I'm going to go back here to assignments, was to do and look at Mini-Lab B. Mini-Lab B is all about, we'll go over to Mini-Lab B. Mini-Lab B is an astronomy problem. And in this astronomy problem, I'm going to help you just a little bit here, because we needed to have a graph of some data. All right, and I'm going to zip over to our Mini-Lab. You're going to have to go to Desmos for this Mini-Lab. And when you do that, you're going to graph these data. Once you graph the data, you're going to find that the data forms a linear, it adheres to a linear pattern. And the value of A, remember, y equals ax plus b. So A is the slope, and you're going to get a number around 500. In the graph, A shows up as the slope of the line. And in the real world, A means, and it's right here, where 500, because that's what the slope is. A should have a value when you graph it of about 500, 540, 520, somewhere in that range. These other blanks up here, I conclude that there is a linear relationship between the speed and the distance. My evidence for this claim is my graph. Over here, I have speed equals 500 times the distance. And then down here, once we know it's 500 times the distance, our distance is 10 megaparsecs. So we just substitute 10 into our equation. 500 times 10 is 5,000 megaparsecs. And we have medium low confidence in that, because our predicted value is far from the data range, and the best fit line is near the edges of many of the data points. All right. So that's the answer to that Mini-Lab. We are going to continue on with our next lab next time, so be sure and join us.